Hello everyone, welcome back to my channel. Now we are going to start off with the course on MCQs on electrical machines. Starting off with question, if the field current is decreased in DC shunt motor, the speed of the motor will increase, that is B. That means the flux will also decrease and the speed, as speed is inversely proportional to flux, it will increase. So the answer is B. Next, when is the mechanical power developed by a DC series motor maximum? So the answer is when the back EMF is equal to half of the applied voltage, the mechanical power by a DC series motor will be maximum. Now by the formula you know that P is equal to EB into IA, that is back EMF into armature current, and we know that EB is equal to VT minus IARA, where if we find out IA, then it will be VT minus EB by RA, and the power will be, in this power formula we'll be writing the value of IA. So this will give us on maximum power output, will be differentiating it with respect to EB. So the answer will be VT by 2. So back EMF is equal to half of the applied voltage. Next, what is the shunt resistance component equivalent circuit obtained by a no load test of an induction motor representative of? So the answer is it represents only the core losses, that is B. We know that no load loss is equal to core loss, friction and windage loss, and no load copper losses. But when the shunt branch resistance RC in the induction motor is equivalent, does not depend, or it doesn't represent the no load losses. It represents only the core losses of the induction motor. So the answer is B, that is core loss. Next, in the Ward-Leonard system, the lower limit of the speed imposed by, the answer is residual magnetism of the generator, that is C. We know that the lower limit of speed will be imposed by the residual magnetism. Next, Ward-Leonard control is basically which type of method? We can control what parameter? So the answer is Ward-Leonard speed control method consists a motor with a constant excitation and applying a variable voltage to its armature to provide the required speed. Hence, it is armature voltage control method. So the answer is C, that is armature voltage control. So Ward-Leonard method is used for the armature voltage control. Next, for very sensitive and wide speed control, the preferable control method is. So the answer is, we just saw that Ward-Leonard control is very useful for the speed control, for sensitive and wide speed control. So we know that very fine speed control over the whole range from 0 to normal speed in the both direction can be obtained from this method, and the motor generator set can be provided for the speed of both below and above the rated speed, and it is in the both direction. So the answer is B, that is Ward-Leonard method. Next, eddy current loss will depend on which parameter? So eddy current loss depends upon the frequency, flux, as well as the thickness. We know that eddy current loss is equal to K F square Bm square. So it will depend on all these three. So the answer will be D, that is all of the above. Next, hysteresis loss will depend on which parameter? So we know that the hysteresis loss is equal to KH B to the power 1.6 into F. So it will be dependent upon only frequency. So the answer is A, that is frequency. Next, thin lamination are used in a machine in order to reduce which loss? So the answer is it is reduced to reduce the eddy current losses. Mainly these laminations are done to reduce the eddy current loops. So when these loops are minimized, the eddy current loss will also decrease. Next, hysteresis loop represent the area of which of the loss? So the answer is it will reduce hysteresis loss. We know that it is used to find out the BH loop curve of a magnetic material. Next, commutator pitch of duplex and a simplex lap winding are respectively 2 and 1. That is answer the option number B. It is defined as the distance between two ends of the same armature coil which are connected. So the difference in the duplex winding are 2, as there are 2 turns in the duplex winding. So duplex has 2 and the simplex winding has 1. Next, the EMF induced in the DC generator armature winding is, so the answer is AC. So the EMF induced is AC in nature, but we need DC current from DC generator. So to convert this AC current to DC, we use commutator. Next, commutator in a DC generator is used for converting the AC armature current to DC. We know that in the previous question we just saw that it generates AC EMF. So to convert that, we use commutators. Next, a DC generator without commutator is a AC generator. So if it doesn't have any commutator, it will act as an AC generator. So commutator is mainly used to convert the AC current into DC current. If the commutator is not present, then it will act as AC generator with huge losses. Next, in DC machine, the yoke offers both A and B. That is, it will provide mechanical protection to the machine as well as flux path completion. So A and B both are correct. So the answer will be D. Next, in a DC machine, 72 number of coils are used. Find the number of commutator segments required. So we know that in DC machine, number of coil is equal to number of commutator segments. The answer will be 72, that is C. Next, in a DC generator, brushes are used for collecting the current without any sparking. So brushes are used to collect current without any sparking. So in case of DC generator, the brushes need to collect current with minimum sparking, which is known as successful commutation. Next, which of the following type of brush and their application is or are correct? So carbon brushes to normal ratings, electrographite to large ratings, copper graphite to low voltage high current density, or all of the above. So the answer will be D. These brushes are used with respect to the ratings only. So the answer is D. Next, which of the following bearings and their uses are correct? Ball bearings to small machines, roller bearings to large machines, neither one nor two, or both A and B. So the answer is both A and B. We know that since ball is a sphere, it only contact the inner and outer rays at very small point. As the contact area is very small, so the ball bearing is overloaded. The balls can deform or squish the running bearings. So the answer is D, that is both A and B are correct. So ball bearing to small machines, whereas low roller bearing to the larger machines. Next, which of the following windings are necessary in case of all DC machines? So the answer is A, that is closed winding. Lap and wave windings are used based on the requirement of voltage and current levels, but winding of DC machine is closed winding. It is never short pitched. So the answer is A, that is closed winding. Okay, so if you like my videos, you can also subscribe to my channel. And if you have any doubt, you can always ask me in the comment section below. Thank you.